Hi Professor, my name is Archisha Sasson and I am in your 008 section. So I'm going to be doing option 2, the chi-square goodness fit test, all of that stuff. Okay, so this is the dice that I am using. I will prove to you that it is 6-sided only. So here's 2, 3, 4, 5, 6. Okay, so 6-sided die. You made it very clear in your instructions that I could only use a 6-sided die, so here it is. Okay, so I'm not sure if you wanted to see me rolling the dice on my table. I will tilt my camera down for you so you can see it. However, half of my face will be cut off, and I have been trying to figure out a workaround. Don't know how I can work around that. So here, I hope this works. I hope this is good enough. Okay, so I am gonna be using an Excel sheet, and then I'm gonna transfer everything over to a Word doc so that I can send you the data as well. So yeah, okay, let us get started. 3, 2, 5, 2, 6, no. There you go. Seventeen, 18, 19, 20, 1. Oops, I'm not gonna count that. Okay, awesome. Okay, so now that I have gotten all of my values up until 100, I'm gonna go all the way up. And this is why I did it on the Excel sheet. It's easier to organize all the numbers. So I am gonna go up here to the top and I'm gonna copy this, put it over here, and then I'm gonna sort this from smallest to largest. So what that does is that now I'm able to put in a formula that's gonna count all these numbers for me, basically. So over here, I'm gonna go to formulas, I'm gonna go to recently used, I'm gonna go to COUNTIF. So for COUNTIF for the range, I'm gonna do this. For the criteria, I'm gonna do equal to 1. And that should be good. So that'll be 10, as we see over here, 10 ones. So it is accurate. And I'm just gonna take that and copy paste that over here. And over here, I'm gonna do count the number 2, and then count the number 3, and then count the number 4, count 5, and count 6. Okay, so this is what we have so far, with our faces being on the left side and the number observed on the right side. Sorry, that's my dog going a little crazy. Okay, so just to double check that the formula actually worked, I'm gonna calculate it so that we can see if it adds up to 100. So 10 plus 21 plus 19 plus 15 plus 14 plus 21. 100. Okay, so the formula has worked. It is accurate. So now I'm going to transfer all of this over onto a Word document so that I can send you a PDF including all of the data. I don't want to take any chances. Okay. Okay, I'll submit that to the Word document. I transferred all my data over and completed the calculations. I think it was okay to do the calculations off camera because I did not see in the instructions anywhere that the calculations had to be on camera. So I'm hoping that it's okay. So this is the data I collected. This is what you saw on the Excel sheet a little bit ago. The number 1 came up 10 times, 2 came up 21 times, and so on. And since I'm doing a chi-squared goodness of fit test, the expected frequency was the same throughout everything. So it was 1/6 times 100, which was 16.67. Okay, so now I'm gonna go down to the calculations. So the null hypothesis was that the die is fair, and the alternative hypothesis is that the die is not fair. For this test, we used a significance level of 0.05. Okay, so we are performing the chi-square goodness of fit test, and the assumption is that the sample size is large enough. It is, because it's a sample size of 100 rolls, and the expected frequency for everything is greater than or equal to 5, which is true, because our expected frequency is 1/6 times 100, which is 16.67 for everything. Then I just rewrote the observed frequency and expected frequency. The observed frequency is 10, 21, 19, 15, 14, 21. And then the expected frequency is 16.67 throughout. And this is the formula for the chi-square test. Okay, so here I kind of just calculated everything out. Did I move anything? No. I calculated everything out and I got 5.84. Okay, so my chi-square was 5.84. So then I calculated my degrees of freedom, which would be 6 minus 1, which is 5. And then our critical value was 11.07. So the way I got 11.07 was from the chi-square table. The degree of freedom is 5, and the significance level is 0.05, so I just saw where it met, and it was 11.07. So since our chi-square is less than our critical value, we fail to reject the null hypothesis. Therefore, the die appears to be fair, and the differences in frequency must be due to chance. So this is it, I believe, for my extra credits. Let me know if I missed anything. Thank you for taking the time to look at it, and I hope you have a great winter break. Thank you.